Yeah. Can people hear us online?
Yes. Yeah.
Yes. Yeah.
Perfect. Evening,
Yeah, I
everybody.
can hear you.
I have hit record as well, so for anyone that doesn't want their face on the camera, please turn your camera off.
Thanks, Joe.
Thank you.
Great.
Yeah.
Okay, cool. So just welcome everyone. So welcome to Modern View of Infrastructure Maintenance, presented by Owen and Chris Duffy. For the people in the room, so the toilet's just outside. We've got the tea point around the corner, and there's no fire alarm plan. So if the fire alarm does go out, take the stairs down to the ground floor, and we must outside underneath the arch. Okay. Thanks everyone for joining in online. If you're able to keep yourselves on mute and cameras off throughout the presentation, and if you any questions you have, please feel free to put them in the chat, or we can ask you at the end of the presentation. So a bit of few updates. So the York and the West Yorkshire section have now combined to be the Yorkshire section. So this won't make an awful lot of difference to people that much. It just means it's easier to dial into events that are based in Leeds. So there should be more events for us to attend. And in terms of next events, so our next one is in September, which is Gareth Dennis presenting in York on challenging conventional approaches to line speed improvements. And that will be here in George Stephenson House and online. Okay, so I will introduce Chris, so the programme manager for modernising Network Rail's East Coast route. So hopefully you'll take us through the basic principles of a multidisciplinary maintenance regime, considering how the initial spec of a renewals enhancement scheme can impact maintenance through to tools and techniques being deployed to change how the asset is being maintained through its full life cycle. So yeah, particularly relevant topic given the changes being introduced within Network Rail as part of the modernisation programme. So yeah, over to you, Chris.
Okay, evening everybody. It's a real privilege actually to be doing the first presentation to the Yorkshire section. I think it's really good that we've come together to support each other, and we are in different times. So we've got to do things different. We've got the hybrid meetings. It gives us the opportunity to draw on the experiences of people across the different sections. So thank you. I am doing this inaugural one. It should be Dave Morgan. Apologies to anyone if you're disappointed. Please do feel free to leave if you were expecting changes in track work safety. Dave's unfortunately unavailable, so I've stepped in. There were a few things in my presentation that I was planning to give a little bit later on. I was due to do this in November, when we will have introduced the changes for modernising maintenance. So this is really looking forward to, well, it's giving an overview of maintenance. So who in the room, and won't be able to see online, but who would consider themselves to have a maintenance background? Okay, so we've got, for those in the room, we've got 5 hands, which means that others don't have a maintenance background. So I don't know how much people actually know what we do in maintenance. What is maintenance? Is it just the really irritating thing that happens every Saturday night, and the dirty people in orange and things like that? Maybe a long time ago, it wasn't people in orange. It was people just in an orange bib. I was going to come in full PPE and sort of show the PPE through the time, but I'll leave that one to Dave Morgan for later on in November. So what I'm hoping to go through today is really talk about what is maintenance and what we cover. So thinking about it on a day-to-day basis. How do we do it? Why do we do it? For those of you that aren't maintenance people, designers, thinking about design, how is the infrastructure built? What does that mean to the future maintaining ability of the railway? Is there anything in the decision making that people make now for a design scheme that could influence what we do going forward? Then I'm going to talk about why do we need to be different. There's a lot of things have happened in the world, in the railway, in the last 5 to 10 years, and that is really driving. We have to bring forward this modernisation programme. So we've got to think about what are we going to do differently to support that. Question that I was thinking about when I wrote this is, I left maintenance in 2015. I had time up to being a track maintenance engineer on the Premier Delivery Unit on East Coast. And when off to do track renewals and then enhancements. And I've come back and are we different already? What's changed really since I left? So we keep looking forward and saying what we need to do, but take a little bit of stock of what it is that we've done already. And what else are we going to do? We've got a really big program of modernising maintenance that's just about to tip over on the 9th of October. And it's just a few principles of that. And when I started putting this together, I did put this as a modern approach, but actually I thought what might be quite useful is just talk about where we're at, some of the principles of it, and then maybe come back again in the new year and say what we've actually achieved through modernisation. Like I say, it's supposed to be November, so really focusing this on some of the things that we do. So what is maintenance? Maintenance is part of the asset management system. We've got to do a load of things to keep the railway operating. Maintenance is a part of it. We've got to do some renewals. We can't renew everything. We don't have the money to renew everything. So we do some refurbishment. We might change a couple of components, but that can have a massive impact on performance, all the way through to the massive enhancement schemes that change the way we operate the railway. But at the end of the day, for this system to continue to operate, we've got to do some maintenance. And that's something that we look at. So what is maintenance? What do we cover in that maintenance world? So the part of that, as imagine the maintenance there, we do our MSTs, we do our work horizon, and we do our response work. So what are MSTs, I hear you say? So maintenance schedule tasks, we're mandated to go out and do work on a cyclic frequency that's driven by our standards to say, to get a safe and performing railway, go out and do some work on a cyclic basis. And we've got, for all the different disciplines, typically they'll independently say, go out and do this stuff. And that contributes about 46% of the work that our direct workforce do. So pretty much half the time, we're doing something that's told to us to get out there, go and have a look, go see, go tinker, go clean, go inspect, maybe go change some components. So we do some cyclic placement, but it's saying on this frequency, go do this stuff. That stuff that we do will then generate these inspections, generate some work that we might say, actually, we've gone out and we've done a track patrol, we've done some inspection, and this needs changing. We've got these bolts that are loose. They're always loose. Why they're loose? Because they're worn. We're going to go and change those bolts. So we do work horizon, and that is then the work that's generated. It doesn't tell us we have to do it on a specific frequency. These are the things that we find that we think we need to go out there. We will prioritise that. We will fit it into our work banks, and that contributes to just over 40% of the work that we do. So the most significant part of our work is go have a look, and then from that we will have some items that we will plan to change. And disappointingly, 11% of the work that we do is going and fixing faults. So that 89% hasn't stopped the railway from failing. That hasn't stopped service affecting failures. It means our customers aren't getting to the destination on time. And just to put it into context of what does that mean? For East Coast Route, our direct workforce, so our operatives, technicians, team leaders, they do just over 300,000 hours of work a year. And that's physically where they're doing something. That doesn't include the travel to site. It doesn't include the staff that are needed for protection. It doesn't include the person that's a level crossing attendant to help a union mob get on. So this is actually the work that we're doing. So the hours that we actually need from our workforce is considerably higher, somewhere in the order of 1.1 million hours we need available to us so that we can do this 300,000 hours of tasks that we're told to do on a cyclic frequency, some work that comes from that and the inspections that we do. And sadly, when the railway doesn't perform, we've got to go out and respond. So all of this is a sum of the work that we do. How much of each of them we do can drive something else. The more work horizon we do, chances of faults occurring goes down. Do really good quality inspection, and those tasks that we're told to do again can influence this. But where do we get the time to do this properly? Well, we need these faults to go down. we need for these faults to go down, we need to do the work properly. So we're in a really difficult conundrum of how do we balance this equation and ultimately bring this total time down, because we don't want to be going and doing all this work and this inspection. We want the system to perform. So the better it is, quite often, the less actually we need to do. So for those of you that aren't from a maintenance background, a little bit of how do we do it, getting ourselves into the mind of the section managers, the people who are out there day-to-day planning these works, the engineers that are overseeing multiple section managers across that discipline, because we are discipline engineers, we are discipline section managers. So as a former track maintenance engineer, I looked after 3 track section managers, an off-track section, a technical section, rail testing and lubrication, and also welding and grinding. So Dan was my S&T engineer. We worked together. Dan had section managers, technical support, the sinks type people. So we were looking after our disciplines. So what do we need to do? We've covered that with the standards drivers to do our MSTs or the work arising. So we know what we need to do, and we know when we need to do it, and we get a compliance window. So for a task that we would look at doing every year, what happens if we don't do it on day 364? What happens if we do it on day 365, 366, 400? Is it as critical as a task that we should do every 7 or 28 days? We have to do these things more frequently because there's a risk associated with them. So we know what we need to do. And we have a team of planners who use a system called Ellipse, if anybody's heard of that. That's our work scheduling tool. It's also becoming our master asset register for S&C assets. So we're using this to say what we've got and where we need to go. It's a great tool when we use it effectively. For an MST, it says you've got to go to York Station to 882 points, and you've got to do this task every 28 days. So if I do it today, in 28 days' time, it's going to tell me that it's going to happen again. And then 28 days after that, it will continue to tell us the work that we need to do. So we know what we need to do. We know when we need to do it. So now we've got to really think about how we're going to do it. And that's where things are really changing for us. So we used to quite often go out with just our hard hat, and not even our hard hat when I first started, just our orange vest and our boots, and we'd have some flags and we'd walk along and we'd go and inspect whatever it is that we want to do. We can't do that anymore. And I'll come to that later on. So that's where Dave Morgan's part of the change in track worker safety will really tell us about what's changing and why. So we have something called signal box special instructions now. So this says we know the task we need to do, we know where it needs to be done, and really trying to build it up that we've got an access regime that matches what our maintenance regime is. So at least if we know we've got to go do something, don't plan to do it at 3 o'clock on a Tuesday afternoon when trains are running. That because we know we've got absolutely no chance of doing that. So we've really got to think about when we're going to do the work. And when we've thought about what we need to do, when we're going to do it, in the access that we're going to do, we've then got to try and find the right people with the competencies to work on that HW point motor. And then the next activity they've got is a clamp lock to maintain. Then they're going to go and do some level crossing maintenance. So wherever all of these things fit, we've then got to make sure we've got the right people with the competencies to do it. So then, how do we do it? Maintenance, I would describe, is a complex portfolio of relatively simple tasks. So if we're going to go and do some facing point lock tests at Shaftholme Junction, it's quite easy to plan that because we'll just look at our people and we'll say, we're going to go to Shaftholme Junction. If we're going to do a facing point lock test on all of our point ends, it's quite simple because we'll get a program and we'll go and do it. We've now got to do that every 28 days or every 6 days or every 91 days. So it starts to get a bit more complicated now around where's the access, who are the people, who's on holiday. And you can see we're getting a little bit busier. We're just in the mind now of a signalling section manager at Doncaster thinking about the facing point lock tests on his 307 point ends, I think it is. that it looks after. So still manageable. But what then happens when you add in your location case and track circuit maintenance? Because Ellipse has told us what and when we need to do something. So this has kicked it out. So now these relatively simple tasks is in quite a complex portfolio of work. And then our friendly P-way section manager comes along and says, I've got a half set of switches that needs changing. And the welding and grinding section manager comes along and says, I've got a set of switches that needs grinding and I need a facing point lock test to be performed after it. And then somebody else comes in and says, I've got a 650 power cable that needs to be replaced. And all of a sudden that portfolio of relatively simple tasks is really complex because we've got all the different tasks we need to do, all the different competencies we need, all the different access footprints. And then you think about it of what is the access? So how do we do this? So this is what we're moving towards of our signal box special instructions, where you can only get in certain places at certain times. And if you look at the colours in here and here, well, you can get on the fasts at one time and you can get on the slows at another. So we've now got not just planning by geography, even the line at that place where we're going to, we can't get all of it. And if we're doing a crossover, we might be able to get on one end of the crossover, but we can't get on the other end of it because there's trains running on there. And that isn't covered in our signal box special instruction. So you get to a point now where actually, with a really heavily congested railway, with the work that we need to do, the 308,000 hours of MSTs, work arising, and faults that we need to do, because this is all a plan. When your 11% of your faults come in, that goes out the window, and you've now got to somehow recover it in one of these access windows with all the other things that are laid up. It starts to be quite a complex task that the maintenance teams are undertaking. That was just the section manager signalling at Doncaster. We've got 39 section managers on East Coast, 39 other section managers on East Coast route who are every day having these thoughts and trying to work out, how am I going to deliver this? So the priorities that we've got just in maintenance, before Rob comes along and says, I've got some surveys that I want to do, there's some information that I need to see, I want to go have a look at such and such. There's an enhancement scheme that we're looking at and we want to do some Grip 3 surveys. Before these even come in and start to think about the other work that we want to do, this is what our maintenance teams are thinking about on a day-to-day basis. So, you'll agree? We want to be looking at doing something different, don't we? So, have we changed? When I left, remote condition monitoring. As we move into a digital age, and we've don't know how long we've been in a digital age, how long have we described ourselves as being in a digital age? But we've got radar. Anyone in the room know what radar stands for? Anyone remember what the acronym of radar is? Can you, Dan? No, I can't. No, it's got an acronym. I can't remember. But this is a way that we saw this when we had the presentation for Keedby. Actually, if we can start to instrument in some way our infrastructure, we can start to remove some of these activities, and it's going to tell us what's going on. So I've got an example here. You'll see from 2019, I asked our flight engineers, intelligent infrastructure technicians, I think they're now called, give me some screenshots of some good stuff for a PWI presentation. And we go back to sort of 2019 because things haven't really changed that much. So point heaters, we can see the state of our point heaters if they're turned on or they're turned off. So instead of now having to go out regularly to check, have they just turned themselves on by mistake? Has someone done something to turn them on? We can start to get alarms that would say, in some of your point heaters are on. That's not a good thing for hot weather management. In winter, your point heaters are not on. That's not a good thing for running trains on cold mornings. So it can start to alert us to failures that we've got. So we can plan a little bit more of, if we get an alert at 3 o'clock in the afternoon now, for some point heaters that aren't working, actually, I don't really care. I'll go in tonight because it's going to get cold a little bit later. And we can plan now to go in and do our response rather than we find out at 3 o'clock in the morning when the signal tries to swing the points that those points aren't working, and we are in a much more reactive state in the position we're in right now. So we can start to instrument things, and this is us moving forward. So that's a winter example. What about in summer? Again, remote condition monitoring. How hot is the rail out there? We know how hot the point ends are because we've got some probes on them. So what about using that information for finding out how hot the track is in summer? So we use this technology in winter to know our points heating working and the temperatures when they'll come on and they'll come off, turn on and turn off. So what about now using this for more than one area and thinking about it for temperatures, rail temperatures? So you can see here someone in July was thinking about rail temperature. Great. We've got some red flags. We can set what these alerts are based on the different critical rail temperatures we've got because of the work that we've done, the asset condition, and it can start to drive us to do respond because the infrastructure's now talking to us. So that's kind of a little bit of what we do. Some thoughts from when I left maintenance of what we were looking forward to of a more modern approach. So why do we do maintenance? Why do we do some of it? So Heart of the Curve up on the Northumberland line, I was involved in the enhancement, and as an ex-maintainer going into an enhancement scheme, I sit and I think, why are we doing this? What can we do to make the life of that track section manager easier? And Heart of the Curve pops up. And it's got 198.4 metre radius. There is nothing we can do to design out the curvature here so that we can make this CWR, because it being joined to track, we need to go and patrol that 2 weekly because we've got the risk around the fish plates breaking. If it was CWR, the LPR could go up and down here. So actually we're constrained quite often by what was built in the first instance. That's driving us that we have to do something. We can't embrace some of the additional technologies that we've brought. So we are in some ways constrained. Makes it even more fun because there's a level crossing in the middle of this 198.4 metre radius curve. That makes it really difficult to maintain the level crossing. It makes it really difficult to maintain the alignment through that curve. It makes it really difficult for it to be safe because of the skew that we've got and cyclists and all the good things that cyclists like to do. So now we've got a real challenge around the curvature from the track perspective, got a real challenge around level crossing surface. There's not a lot now from an enhancement scheme that we can do to design this out. And there's an IRJ right off the crossing because level crossings apparently need IRJs to say that crossing's clear. So again, is there anything we can do now? Because we've got some additional components that present an additional risk. Well, actually, yeah, there's an enhancement scheme going on here. We're doing some recontrol. So we're bringing in some different technology. We can bring in axle counters. They have a maintenance regime themselves, but they can eliminate IRJs. So if we can get rid of the IRJs, it's a failure mechanism that can be removed. It's the 11% of faults. We're reducing the opportunity for broken rails at those IRJs. We're reducing the opportunity for lipping at those IRJs. And so now through the enhancement scheme, we can start to think about helping out that maintenance team and where these are positioned and what we're doing. So there are times where through an enhancement scheme or a renewal, how much of the future maintainability are we really thinking about? And I'll just share this example with you. I do not know what this person was thinking about, but this is a location case on the Northern City line, a part of East Coast Digital, the trial stuff. See the yellow line? What does the yellow line mean on a platform? What does it mean? Do not cross if trains are running. Our safe systems work. If we're going to be within 1.25 metres of an open line, we need protection. The only way we can maintain this infrastructure is when no trains are running. So if one of our telecoms friends wants to just go and open it up and check that the lights are still flashing and see it's not too hot, great. We'll have to wait till Saturday night to go and do that. Or where else do they need to be on Saturday night? Is there anything else more critical that could be doing? So how we build the infrastructure really can make a fundamental difference to that complex portfolio of relatively simple tasks. So it's one location case. All right, you've got to go to one location case on Saturday night. You layer that up with what that section manager is dealing with and what they've got to plan elsewhere. And actually it is now becoming quite a burden, some of these points that we've made. So this is East Coast Digital. They're not all bad. Not all bad. So as part of their work, what are they thinking about how maintainable the infrastructure is? So they've assessed they've got 161 locations as a part of their scheme that they've got to work on. And without any improvement works, 130 of them would be all right. We don't need to cross the line to go and do some maintenance. These are maintainable. We don't need to stop trains, go across. There's 31 that would require one or more lines to be crossed. So actually that's not that maintainable, because if you want to go and look at something whilst trains are running, you can't look at 31 of them because you can't get to it to physically do it. But as a scheme, by doing some improvement works, 26 of them, you don't need to cross the line to anymore, because they put in 9 new access points and they put in 1 new safe walking route. And now there are only 5 of the 31 that need crossing line. So as a part of that scheme, it's looking at additional scope that thinks about that future maintainability. It's thinking about the end user. It's thinking about that complex portfolio of relatively simple tasks. It's going and looking at 5 loads. Hey, it's 5 loads. It'll take 10 minutes. But if we've got to wait 10 to 20 minutes for 31 of them to cross the line to go and get to that load, what do you know? You've got to wait 10 to 20 minutes to cross back as well. And that 10-minute task has now taken you 20 to 40 minutes just to get to do that 10-minute activity. Okay. So why do we need to be different? July 3rd, 2019, Gareth and Spike were killed at Margam. They were doing an activity that, when we looked at it, the RAOB report said, we didn't need to do that. We've got people out there undertaking an activity that they probably didn't need to do. We've got 141,000 hours of MSTs that it tells us to go out there and do. We do 131,000 hours of work arising that somebody's prioritised. That probably we didn't need to do in this instance. We had people out there on the operational infrastructure exposing themselves to risk that the system didn't need to mitigate. And I think that that's a really good reason for us to think about doing something different. Sadly, it's not the only reason. In February 2021, at Surbiton, track patroller struck and fatally killed. Track inspection is really important, but is it open line working? They were inspecting 80-mile-an-hour infrastructure with lookouts and struck and killed. Was that the only time that they could have done that activity? Planning that one track patrol, you can do that on Saturday night. You fit that one track patrol into that complex portfolio, and actually maybe now Wednesday does become the only time you can do it. So 2 really recent examples of why I think we've got to be doing everything we can to look at a different way of doing maintenance. That's looking back. If we look forward, again, we've got to do things differently. We've got our decarbonisation targets to do, to meet. Going out and driving 100 miles to go and look at something and clean it and such and such. it's not a particularly positive impact on the railway. And even if we do move to electric vehicles and we make a dent in the 33.5 million quid that we spend on fuel every year, do we need to be there? And if we do drive 100 miles in one of these vans and we go and look at something, when we get there, do we have enough range in these vehicles to get back? So how are we going to then integrate our future aspirations for decarbonisation to do our complex portfolio without doing something different? How many people in the room are from a route engineering and sponsorship world? You think about it from how many D&P upgrades, DNO upgrades do we do? How many times do we say, point heaters are up? We've got an S&C job from your old days. How many DNO upgrades did you have to do because the point heaters needed 200 watt strips rather than 150 watt strips? How many times did we say, do you know what, let's look at the capacity for just charging 2 vehicles? When we get that DNO upgraded, so the enhancements or the renewals or enhancements that we make, how are they thinking about the future maintainability? Because if we can't drive to site and back without doing some charging whilst we're out and about, we've gone out, we've done the 20 minutes of waiting to get across the line, and we've done the 10 minutes of cleaning, and then we've waited 20 minutes to cross back over. That's 50 minutes of charging that a vehicle could have done. Fast charging, it could probably have charged it up again. We don't do that. We've got to plug it in tonight. And that means that vehicle is now not available for the next shift. That means we've got to increase our road vehicle fleet. That means we've got to spend more money on it. That means we've got less money to spend on everything else. That means we've got to think about, have we charged the vehicles in? How big's our depot? Do we need more car parking? We've got all these planned tasks to do, but someone forgot to plug the van in and we can't get anywhere. So what we do and what we specify and how we think about some of our schemes can really make a difference to, in 5, 10, 20 years, what we're doing to maintain the railway. Okay, so what we're going to do differently. If you are a designer, someone from sponsorship, anything like that, please build different infrastructure. Please design out any maintenance. Please think about the end user when you're designing your scheme. Because for a section manager doing that one facing point lot test, it's easy. When you layer everything else up on top of it, it's not. We do 308,000 hours of work. If we can mitigate or manage or design out or install something that means that we don't have to spend so much, 308,000 hours is just the work we do. It doesn't include the driving to site, the setup, the machine controller, the points operator, the level crossing attendant, the additional protection, all those other things. There's a huge efficiency that we can make. And we are in a cash constrained industry. Most parts of it, if not all parts of it, we'll be seeing how can you squeeze your CP7 plans. Do we spend the money on some of this, I call it waste, this extra stuff that we do that we don't get value from? Or if we can squeeze that down, we've got more availability to do the really good stuff that might mean that we don't have to do as much of the maintenance schedule tasks. We don't have as much work arising. We don't have as many faults. And we're really feeding into making a dent in them 308,000 hours that we have to do. And what does minimum viable product mean for the whole life cost of the asset? I've been on an enhancement scheme where I have quoted these words. I have been looking at what do we do. There are times where, do you know what, we've only got a certain amount of money. We're going to have to make some decisions. It's not what an engineer wants to do. An engineer will want to make it twice as heavy and 3 times as big, won't they? Because that's going to be really strong. But if we don't need to and we don't have the money to, we can't. So are we applying MVP to the right things, the things that are just going to get the scheme over the line? Actually, some of the times, if we approach somebody else, there might be a pot of money that might help this, that in the long term, it pays for itself. Okay, so again, what we're going to do differently. I'll make no apologies for sharing this. Remember it from earlier. Recommendation 1 from Markham. Are you doing work that is unnecessary? Are we exposing our people to unnecessary risk that the system doesn't see a benefit from? So, give me, there's an animation there that I don't need. Looking at reliability centered maintenance. So thinking about how the asset performs, how do we want it to perform? What do we want it to do, and the tolerances? If it fails, what's going to happen? Does it fail safe? Is there a risk? What's going to cause it to fail? What happens if it does fail in this way? Does it matter if it fails? A load of things that the principles of reliability centered maintenance we're adopting in the railway. How pure we are, not entirely sure. But for that section manager that's got that complex portfolio of tasks to think about, actually, they don't care how pure it is. Is my asset going to perform? How much work do I need to do? How many faults am I going to get at the end of it? It's really going to help us to do things differently. So what could that mean? Bring it back to a track example. For a timber layout, we will go and inspect that every 7 days. For a fully welded concrete layout with shallow depth switches, we'll go and inspect that every 14 days. So we're sending people out there, S&C, high risk asset. We're going out and look at it probably every 7 to 14 days. We also go out, as we call these, our level 1 inspections, our basic visual inspections. We have supervisors who will patrol that same S&C. They'll go there every 8 to 13 weeks, and they'll be looking at slightly different things. They're not just looking at, are the bolts intact? Are there any loose clips? Is there anything else going on that's an immediate risk to safe running of trains? They're looking at a slightly broader horizon. How well are the patrollers doing it? Are there any repeat faults? What could be happening over the next 26 to 52 weeks? Have I got any risk of things like flange back contact? Have I got any damage to the switch blades that could be a derailment risk? So they've got a different lens that they're looking at. So you put those together, we're going to these places every fortnight. Someone else goes there at another time. So what could a risk-based maintenance regime look like for track? Well, actually, we could be going to things between 13 and 104 weeks. And this really is going back to those thoughts that we had about what's going to fail, how could it fail, what happens if it fails. We can then start to break something down, really complicated, but if we now think about it as the different components fail in different ways. Different components fail at different rates. So different components probably need different inspection regimes. And if we can go and do some work, that's going to help the asset to perform. We're doing less of the just inspecting, more of the doing. So this is where we will go and we will do some tactile inspections. So instead of going and just looking, we'll take tools with us. We look less often, but we do more when we're there. So we actually can go every 13 weeks and we're only going to do these tasks because these are tasks that need to be looked at every 13 weeks. There's some other things that need to be looked at every 26 weeks. So the next time we're there, we'll look at a few more things. The time after that, we might move some of these other activities around. So we're getting a meaningful shift. We're going and doing some work. We've taken some tools, we've done something, we've tightened some bolts. But why do we do maintenance in the first place? Because we've designed it that way. So you'll see here, modular bearer shrouds, great for installation, isn't it? How much easier is it to install things modular? How much less access do we need? Weekends are a peak and everyone wants to go on their fun times on a weekend. So the less disruptive access we take, we've got a technique now that we can install things and actually be less disruptive. We can take shorter possessions. But because we've now introduced that component of the modular bearer shroud, that has a failure mechanism. That failure mechanism we need to go and look at every 13 weeks. So how we design something, how we plan something, has a direct bearing on how we have to maintain that until the next time we renew it. So just thinking about that, of every decision we make in a sponsor, in a planning, delivery, design world, can have an impact. Going and looking at a bearer shroud, hey, every 13 weeks I can plan that. Layer that in with the complex portfolio of all the other tasks we've got to do, and actually we're now adding to that burden section manager. Going to go do something differently on plain line. So again, what does that mean? We've got shop glued IRJs. These are glued, hook bolted. You'd have the bolts that can come loose. It's a different construction technique. They have different failure mechanism. Through our RBM principles, we go look at them every 26 weeks. But if we install a drive IRJ, or we leave them in because we're an enhancement scheme that's looked at minimum viable products, for someone to come and implement a risk-based maintenance regime, we've now introduced this activity, which is fine because we're here doing some other things. But if we could design out these other things, then actually this could be the limiting factor. So whilst we're there anyway doing it, it's fine. We've got to go to site. We've got to go look at the switches for flange back contact. We've got to go do the crossing check rail fastenings. It's fine. We can just look at the bearer shrouds. But if we can mitigate the other points, well, actually this now becomes a burden and it's driving us to go there. So why do we need to be different? Make no apologies again, coming back to it. Last few years, we've had people out there doing work at times, but it's essential work. But there's a different way of doing it, but the different way maybe didn't fit into that complex portfolio. So we really do need to think different. So what's it going to take to think different? It takes a bit of engineering, a bit of innovation. So we've got one of our E&P maintenance engineers has looked at this and said, we call it a BO1, non-intrusive ground level visual inspection. We go with shine a torch and we look at it. But we don't just do that because we're going and looking at the integrity of the overhead line system, because it's not just overhead. You've got your structure to rail bonds as well. They've got a mechanical fixing, and somewhere in here, this is section 3.6 of a however many page document, we wrote this clause: torque up to correct settings if required. How do you know if a bolt needs torquing? This is a structure to rail bond. We have them every 60 meters or so on both lines, both sides of the track, on a 4-track section, all the way across. We might only be able to get the fast, not the slows, because of our signal box special instructions. How do we inspect the fastening on the main line and the one at the structure as well? Because it's a structure to rail bond, it's all bolted. We need to torque if required. How do we do that? We probably don't, being honest. We'll go along and we'll kick it. I haven't seen any OLE engineers with a torque wrench. Like I say, holding the torch, looking up. So we've got to do something different. So, Jing Yu, you want us to get in this photo? It's Facebook. There's a Yammer post. So, what's this? This is a pin brazing machine. So instead of drilling the rail, putting a bolt through, top, fixing the structure to rail bond to it, and now we've got a fixing that could come loose. Actually, let's give this a whirl. For those online, there is no audio. Bear with. Okay, pin brazing machine. So we do. It's not sharing that, is it? You were right. Technology. Shouldn't have gone for the video, should I? Got a hand from Joe. Come to the video later. Come to the video late. back on. Comes the video later. So pin brazing machine. What it is we grind the rail and we fuse a pin to the rail. With that pin, we fuse the bond to it, and we now no longer have that mechanical fixing that can come loose. We've changed the infrastructure. We've put a different component in there. We've designed out a failure mechanism, a meter clause 3.6, torque if required, if through our enhancement schemes, if how we sponsor the work, how we remit it, we say, can you pin brace? And this is something Jingy's working through with all the safety stuff. We can eliminate now that failure mode. And we're starting to change the way that we're building the railway. We're starting to change the way that we think about the way components can fail. What happens if it fails? We're now thinking about different, which means that we're taking away some of that maintenance liability. So this really is somebody taking it and going, I've got one thing that's limiting it. I'm going to introduce new technology. I'm not going to be able to do that overnight, but actually we're starting to change that in the future. If we don't have to go and mechanically torque that bolt, what else are we doing? Do we need to stand there and look up with a torch, or is there something else that could travel at 125 miles an hour that's got a camera looking up at the sky that could capture that footage for us, that would mean that we don't need to be there, that we can use that train path that's stopping us getting on anyway to hopefully help us to inspect. So I left 2015, went to get high output. Are we different? Let's look forward. Sadly, in some ways, I'm going to say no. This is a table of the different grades in East Coast roof. This is how many of them are female. This is how many of them are male. We don't have any engineers, maintenance engineers who are female. If we're going to be different, if we're going to think different, there's loads of things that make us different. It's not just about fitting pin brazing. It's thinking about us as an organisation. How far are we coming through? How appealing are we? Because everybody is everybody's diverse. I genuinely believe that people bring different ideas, people bring different ethoses, people bring different work ethics, and actually by having a more diverse workforce, we will have different thinking. And I don't think we're really doing that at the moment. So less than 10% of our workforce female. They typically are in band 5, which is quite an administrative grade. They're not in the senior leadership. So I think for a more modern railway, for thinking differently in maintenance, I think we've got to think differently in some of this. So that's just a personal one for me. But are we different already? 308,000 hours of work. If you go back to January 2022, this has got some other grades added in, but we were doing around 225,000 hours of work in our MSTs. So we've done some stuff. We've taken some work out, and actually we're down at about 193,000 hours. So the risk-based maintenance, the changes to standards, are we doing things that we don't need to do? Absolutely. Less of it. Still going to be doing some of it, but we are on a journey that we are already different. And if this were to have wound back to 2010, I don't know when Rose came in for signalling, but we think about the progress we've made. Some of the other disciplines, the track example I gave of we could go and look every 13 or 104 weeks. That's really the first example of RBM that I've seen in a formal world. Dan and I did do some stuff when we were at Doncaster of looking at what's the difference between Grantham South Junction, of why can't we go and inspect that in a different way. But that was a one-off 10 years ago and made very little difference. But now we're making progress. We are getting different. So some of the other things that we've got, are we still stuck in 2016? Are we still thinking about that screen? Actually, no, we've got some really different types of rail temperature monitors. We've got Yeltex, we've got much more visual dashboards. We've got Hitachi, This, has anyone seen rave? Anyone heard of rave? Heard of rave? So unattended geometry measurement systems. The Hitachi fleet, I think most of the TPE, some of the LNER, can measure track geometry. So we've got the NMT, the PLPR 1 and 2 that run around on specific paths, get in the way of everything, get wrong routed because there's some other right time stuff that we're trying to manage. Well, actually, we've got trains running up and down the network that can measure it. It's unverified data. Nobody's gone through and checked it for positionality, for rogue data sets. Was the sun shining from the east that morning and it had a problem with the lasers like we get with the NMT? Well, no, it doesn't. But for this area here, we can compare this to the last trace. We can compare it to the trace before. And if this is running every 3 hours on a TPE north of York, well, how many times is it going to be wrong? They're either all wrong, one's wrong, there's a rogue one. We can start to see the difference in it. And now we get a rough ride. The first thing I hear is, oh, I've got a rough ride. Has anyone had a rave on it? I'm like, well, that doesn't sound like a good thing, but we've got a system now. We can dial in, we can see what did the last train through see? What did a train 2 weeks ago see? Not what did our trace last month see. So we're starting to partner with industry and think about who's running, survey once, use many. We've got that path being used. What else can we collect from it? We've got the NMT running up and down. People talk. So can we use the technology that's out there in a different way to help to inform some of the maintenance that we're doing? A lot of opportunity in that space. So what else are we doing? Modernising maintenance. Talked about MSTs. We talked about work horizon. We talked about response. These things we can do some things to manage what the work is. But if you're still telling us we need to do it, we've got to go think about the how. So 9th of October, we're going to go live with modernising maintenance. We're going to introduce changes. We're going to start to roster people individually, not as teams. Doesn't sound a big thing, but can make a really big difference for us. We're going to start working cooperatively. We're not going to be signalling, track, overhead line. We still will be, but actually, if we're out on site and we've got a job to do, I use the example of a rail drill, my favourite. Overheads currently, until Jingu gets the pin brazing in place, overheads will go and drill a rail for a structure to rail bond. P-way will go and drill a rail for a fish bowl. Signalling will go and drill a rail for tail cables. What's the difference? It's the same drill, it's the same course, it has a different bit, you do it in a different place. So what do you need to know that's different? You're competent.
Where to drill the hole?
Where to drill the hole, what size bit to use.
What size bit?
Yeah. So if I ask Dan, what size bit and where do I drill it? I'll go and do it. And when I need a hole drilling, Dan, it needs to be this big and it needs to be there. So we're all competent, we've got capability to drill a rail, but because I'm track, I'm not touching it. Not touching an OLE structure to rail bond. Oh, I'm not drilling that. So work cooperatively. And we're going to introduce joint response teams. So what does some of that mean? If you look at some of the tasks that we do, signalling, picking on them, wasn't expecting the signal engineer to be in the room. So they've historically had 3-person teams. That was the structure. In overhead line, we've typically had 4-person teams. That's what we've been conditioned. That's what we've written into things. And actually, if we can start to change some of these things, let's look at how many people we need to do the task. And let's look at, we'll call it the crew size. In the past, we had a 2-person task. We tend to team 3 because you're a team. You go. That 3rd person's going to do something. It's not all waste, but did we really need that? In the revised working arrangements, we'll send 2 because it's 2-person task. If we need a 3-person task, we'll send a team of 3. Brilliant. We're efficient. We're sending that team and they're doing everything. We need all those people. Well, if you need them people, that's how many people we'll send. If we've got a 4-person task, well, we don't have enough with 3, so we need to send 2 teams, don't we? So that means we send 6 people to do that 4-person task. Well, actually, we could probably do it that we'll send 4 people because it's a 4-person task. We need 4 people, so let's send 4 people. Now, we may have had that this person didn't turn up today, or that person was on a training course, and we sent 5 people to do a 4-person task. And aren't we brilliant that we didn't fill that gap? And we didn't pay some overtime for that shift that we didn't actually need them to do. Because again, people being on track, doing things they don't need to do. We've exposed 3 people to operational risk, where actually one of them didn't need to be there. And it goes through, we'll have the right number of people for the tasks that we're doing. What does it mean if we're going to work cooperatively? So we want to go and change a rail. It's a fish plated rail. So we need the S&T there to drill some holes and to fit a bond. So the S&T are going to be there. They're going to drill a hole. They'll go off and do some other maintenance, perhaps. Maybe they won't. So the people we've got on site, you look at the task that we need to do. We need to disconnect the track circuit or remove the bond. We need to unclip the rail so the P-way can do that. We need to remove the fish plates so the P-way can do that. We need to install the rail. Right, we need 8 people because that's the really heavy, arduous part of it. We need to reclip the rail. We need to reinstate the bonds. We need to test the track circuit. So really high level, going to go do some work. So for that, we need the 8 P-way people because that's how many we need. And we need 3 S&T because it's a 3-person S&T team. If we start to think about working cooperatively and rostering individually, then actually we need 8 people. Where can those 8 people come from? We need 2 people for the S&T. Got to have them because that's the work they've got to do. So now we need another 6 people we've got to find from somewhere because we'll use the S&T team cooperatively. When there is that task that we need someone to say, Rob, can you just give us a lift with this rail, please? Is that reasonable? We think about how we can work cooperatively and we can work together, and ultimately all of this is an efficiency. This means we might have more money for the enhancements. It means we've got some of that waste that's gone. It means we're meeting some of the challenges that we've got from the output of the pandemic, the cost of living crisis. We're in a cash constrained industry. We can do things differently. We've still done the task. We've just asked somebody who was on site, can you give us a lift for this, please? And then looking forward, joint response teams. So instead of just having the S&T, and if there's an S&T fault, they'll go and look at it and go, point failure. Why is the points failed? It's voiding. Let's call the P-way. And the P-way go, well, I can't get there till Saturday night because I've got a complex portfolio of simple tasks, and there's a line blockage, and there's a signal box special instruction register, and I can't get in on the fast until that point. So I'll come back on Saturday night and I'll remove that voiding. And today's Thursday and tomorrow's Friday, and those points fail again tomorrow. And the S&T are not doing that planned MSTs. They're going and responding to the faults. That means all of their tasks that they had planned have gone out the window. They've got to catch up. They've got to look for the next SBSI access window. They've got to look for the next people are there. We had a P-way person there that went, yeah, it's voiding. Let's just take that voiding out. It might be that we still have to go on Saturday night and lift and pack and do some more remedial work. But have we managed that failure? So if we had a P-way person there who'd turn around and say, we're going to take the voiding out. S&T, root cause of this failure is voiding. Can you help me to take the voiding out on these points, please? And that means that we're going to deliver asset performance. We're going to reduce our service affecting failures. We're going to deliver a safe and efficient and reliable railway. We're not going to be called out. We're not going to be chasing the maintenance that we need to do. Is that reasonable? Sounds it. Quite a hard thing to do. So 9th of October, I'll come back afterwards and tell you how it's gone. One final thought. What's next? Well, there's loads we can go at. There's absolutely loads. We're not just thinking about changing the way that people go out there. This is the 153. Really imaginative name. What have we done? We've taken the 153. We fitted some cameras. And where a P-way person used to walk along with a spanner, looking at the floor, The train traveling at 90 miles an hour can go and look at eclipse. It can relay that video footage. And instead of someone being on the infrastructure, looking at something like Tyler was at Surbiton in February 2021, that person could be sat in an office, not exposed to any operational risk, not having to drive an electric vehicle 100 miles that's going to run out of charge, not having to look for where that access window is. The trains run in a path, the hard work's done in pathing the train. And then once we've done that, we can use the video footage and hey ho, what if we fit a camera to the top? Don't need someone to go along and look at the overheads. So we can now run a train. We could start to look at this, the rail, where the rail bond is, because we've pin braced it. It's not going to fail. We don't need to torque it where necessary. We're looking at the clips that are there. Look at the overheads. We can do a TC30 track circuit bonding check because we've pushed out our track circuit annual testing. Like that one, Dan. We can use this train. We can survey once, use many times. We've now taken the overheads off the track. We've now taken the P-way off the track. We've now taken the S&T off the track, and we've run one train. So that's a great opportunity for us. But if we can't run a train, what happens if the train fails? Is there a different way of doing it? Can we fly a drone? Our team in Doncaster over the summer really wanted to manage their hot weather risk for IRJ failures. They can't get in until Saturday night. The plan is every Saturday night, every 28 days, we'll walk through the station and we'll do some work on IRJs. We don't know what we're going to do. We're committing resources when we don't know if there's something wrong. And it's only once every 28 days we can go and do something. Well, actually, they just flew a drone over. They painted every sleeper end pink. Oh, yeah, pink. They sprayed some others yellow. So the high priority ones is sprayed up pink. So let's fly a drone over and look at the high priority things. We can fly it over every day if we want. We've got a really hot day or we've got an IRJ that really is starting to lip over. Well, we can fly that every day. And if it does get to a point, we'll plan it on Saturday night. But if we need to intervene earlier, we can go and do that. Or we can look at instrumenting more virus and see. So we've got some Connex units. I know that there was, as a part of the S&C, the PWI talk in Birmingham a few weeks ago, Ian Puckering talked about Connex. So how do we instrument? What are the ways that we can look at it? We've got our CRT devices. How can the track tell us? How can we get in and have a look at things? How can we use one piece of technology maybe to survey the track and all of us can benefit from it in a warm, safe, cozy environment? And let's all get around the screen like this and see what the system is telling us. Any questions?
Raised it on so people whack over cable now just to make sure it's secure.
Maybe they will. And there's a huge education piece. And how do we change it? There's some of the things that we have to do. We just have to do it. So we don't do open line working in the same way. There was just a really hard line of, right, enough's enough. I've heard Andrew Haynes talk about sitting with Tyler's family and them saying, why you just not ban it? Some things we have to be really draconian on. Some things we can bring people along with. I remember the introduction of hard hats, all orange. We go through these cycles and it's a really tough learning curve in the short term. The sustainability part of it is the challenge, but it does generally plateau and people start to, this just becomes the way. I really believe our apprentices is a way that we need to start conditioning our future organisation. So this year, our latest intake all have gone through first aid for electrical accidents, because if we're going to work as a team, multidisciplinary teams, let's start to get people thinking about working cooperatively. If we're supporting our overheads team for them to take an isolation and apply earths, we need someone with first aid for electrical accidents. Let's just train people. So from the day you come into the industry, we're starting to build that. I really believe that's a slow burn, but a really important one with the apprentices. We'll have some change champions that we know. And there's times where people just say, no, well, you're not the team to start with yet. Let's go somewhere else and let's prove it works. And let's focus our energy at times of, I really do want to come to you, but I don't have the energy to do that. Let's let's bank the success where we can. So we've got to take it, I'd suggest, in a few different ways. Chris?
So does that answer the question? So obviously if you've got teams that traditionally like track, signaling, whatever, but now you're asking them to do tasks they weren't traditionally doing in terms of competence, etc. So how's that going then? So you essentially asking teams to do something they might not actually do their jobs.
I'll tell you next time we come back. We start tomorrow. We start tomorrow. So our Newcastle team start tomorrow with some sandpits. So we're bringing people together, the section managers. So some of these things you say about competency, some of the things you don't need to be competent in. We've written training courses, we've written standards with a certain mindset. It's not just our front line that need to think differently around this. So if we take our training material, we'll say, well, it'll be good. Well, we could just put that in a course. We could just put that in a course. And all of a sudden, we know we just showed everybody it. And people now think you've got to be competent. Actually, no, it was just another assurance mechanism we had that whilst you're here, wouldn't be good if. And removing a pandrel clip is a really topical one as we introduce this change. So S&T will fit their Vortok TPWS grids under the pandrels. So is an S&T person trained to take a pandrel in and out?
Yeah.
Is that a transferable skill? It's a part of the course, but it doesn't need to be a skill. It's just something that they've done. And we've really got to break this down into what's a competence, what's a capability, what's something that just says, help us out with this. So we've got sandpits that are starting. We will get the frontline leaders who do these tasks, who know it, because this is a community. I'm really big on peer groups, because if you don't know how to do something, how did we, 20, 30 years ago, how did people learn how to do a PWA activity? Their ganger would have showed them how to do it. And some gangers would have been good, some gangers would not have been good. We handed a lot down, we formalised a lot of things, but did we need to formalise everything? Or have we just gone, it's great to do all this, and we've created now an industry where we've gone a little bit too far? Some things don't have competencies. We need to show people, make sure people are capable to do that activity, make sure they understand what the limits of it are of, you can do this, but you can't do that. It's all right fitting the drilling the rail, but you can't fit the bolts and the bonds and testing it. People need to be shown what their limits are. And we do it starting some sandpits. We'll get people together. It's a really big thing around the culture that we get, and the non-technical skills comes with that, that we need to be shaping, that we've got the different team dynamics. So we've got a lot of things that we want to try and tackle with this. First and foremost, myth busting, I think, is a really big, that's not actually that bad. We're sitting here and we nod and go, yeah, that sounds quite reasonable. And in a different industry, someone else would nod. But for those people that have done it every day, they're just not thinking that way. So we've got to get them together, show them what we're expecting, watch them doing it, answer any questions they've got, and make sure they're comfortable in deploying these capabilities and really work with them. Got a couple of questions online. Paul?
Yeah, thanks, Chris, and thanks for your talk. It's really interesting to see the proposals, and it seems to make a lot of sense, and the team structure. I'm from an electrification background, so just an observation on the brazing proposal for bonds, or two observations. One is when the East Coast was originally electrified, and fortunately or unfortunately, depending on which way you look at it, I remember those days and was involved. We actually applied CAD welds on the rail to connect the bonds. So we were heating the rail, not brazing, and I appreciate there is a difference, but I'm not an expert, so don't know the difference. But there were two problems with the CAD weld connections. One was the local heating of the rail, and secondly was their reliability. So in proposing the brazing solution, I'm supportive of looking at alternatives and understand that. Just be aware of some of those problems and maybe look back at history and don't let us sort of repeat the mistakes of the past. Secondly, your comment, though, about what are we doing as designers to remove the need. New electrification systems, we connect to the rail far less frequently than we used to, and the legacy that the East Coast is still living with in quite a lot of sections. So originally Hambleton Junction was an interesting scenario where we had, as a result of track circuit requirements, we applied an earth wire through the area and reduced the need for structure to rail bonds. Going forward, providing new and alternative earthing and bonding requirements, particularly in terms of earth wires for connecting all our overhead line structures together, removes the amount of structure to rail bonds and bonding to the rails. So we are taking cognizance of that as a design community and looking to the future. But with some of these, and you're right to say, with your minimum viable products, it's understanding what the consequences are of those short-term decisions on the long-term maintenance. So yeah, we need to work very closely together as maintenance organisations and design organisations and sponsor organisations to make sure that we're not creating short-term gain for long-term pain from a maintenance perspective. But yeah, thanks for the talk and hope that's of some help.
Yeah, it was. Apologies, we had some device sound say. So Paul was saying they did CAD welding in the past rather than pin brazing, had some localized heat issues and some high failure rates. So they are going through it. As a part of it, I say Jingyu's working through it because we do things in a much more structured way now. We do CSM hazards. We'll look at these. We'll test it. I'd suggested why don't we just put hook bolts on? Right, we've already got the bolt hole there. If every time we renew it, that's a way that we can just change the actual fixing itself. And again, they're looking at what can it take from the electrical current? Would it fail if they're in its intended use? So they are working through that. So that's really helpful, Paul. And in terms of removing the need, the less times that you've got those bonds, absolutely. We do want to get to that state of eliminate. Reducing is brilliant. It's how can we eliminate it? Yeah, Alaric.
Yeah, hi everyone. Hi Chris. Yeah, great presentation. Thank you very much. As a designer, certainly a bit more au fait with the challenges that the maintenance community face. My question is, and it's sort of, I guess it sort of brought about another question as well. So my question was, if as a designer, if in your opinion, if I was to go to one person in the world of maintenance to talk about requirements to build into a design, which role would you recommend? And I guess the second thing is with these, I guess, multidisciplinary teams, are there people within the organisation that will be overseeing those teams, so almost like a multidisciplinary engineer?
So tackling the first one, who do we go to? It's through the sponsorship organisation. What is required? You really hope they're consulting the end user, that they've got those interactions with who the end user, be it a maintenance engineer or the operators. I've certainly saw a really good link with operations when I was on an enhancement scheme of actually signalling, of really thinking about ORSs and what does it need to do, and does engage with that really good ops representation on that. I think we just need to be casting the net wide, and also being prepared to challenge back of, we've seen this on a different scheme, what about such and such? Because some of it is just preference. As engineers, we've all got a different opinion, don't we? And everyone else's opinion is wrong except mine. So no, we're not doing that. So we've got to be open to challenge in all of this. And even as we go down to our multidisciplinary teams and individual rostering, one of the things to bring an individual rostering, we're bringing in a resourcing organisation. So it won't be a section manager or their team just filling out a roster and putting it in the bottom drawer, because it's the easy roster that the team like. We've got a resourcing organisation. We all have to be prepared, I think, to accept challenge, because if we are going to have that more diverse workforce, if we are going to have those different ideas coming through from people of different experiences, a designer, somebody else. I left maintenance to go and get broader systems experience and come back, and people are like, oh, he's going to start spouting off about CSM and all this other stuff. And yeah, I will, because I've gone and learned. So if we're going to be quite siloed, and at times in maintenance we saw how many people were male and female. If I'd have said how many of those people have been in maintenance all their life and maybe just taken their boss's job, again, we've got to be open to it. I really think that taking that step to the side and learning about something else. You might be the person that go and do a role in maintenance or somewhere else and get that breadth of experience. So when you do come back perhaps to what might be your home discipline or your home function, if you will, I feel like I've come home to maintenance. That you're just a little bit more rounded as an individual and as an engineer. On to the second point around who's taking the lead. So our teams that are our joint response teams, they've got planned work to do. So typically it will be signalling work that they're going to be doing. The signalling team leader will lead that activity. We do have what's called a lead section manager that we're saying, so who's in charge of thinking what that team's going to do? Typically that's going to be the signalling section manager. The PY and the overheads will follow around, and I keep saying to the other section managers, what's in it for me? You've got to, if you're being told your individual needs to go to Shaftdome Junction, what work have you got to do there that you're not just turning up and you get no value from it? Really think about what's in it for me. What does my discipline need? What have I got at that location? Someone might be taking the overall lead, but you can still contribute to the planning of the work. Is that okay?
Yeah, that's great. Thanks, Chris.
Abu?
Hi, Chris. Yeah, thank you so much for this great presentation. It is one of my favorite topics, is really just driving some innovative solutions and modern change to our everyday maintenance. I come from bridge inspection background, and one of the biggest challenge that I've ever had is challenging organization that have invested significant time and money in a particular method or process. And it's the most difficult thing when you propose a new method and they are using this method that they've recently purchased. So how would you personally go about, I've got my own way of approaching such a problem, but I just want to see from your perspective, how would you deal with this resistance?
How would I personally deal with the resistance? So, well, I'll quote somebody else. I'll quote Rob McIntosh. Rob McIntosh always says, I want people saying how disruptive my team are. I want people complaining, because if I don't hear someone complaining, you're not trying hard enough. And I think I am quite a disruptive person. I'm an engineer. Everyone else's opinion is wrong except mine. So if there is something you do passionately believe in, you've got to make that case to demonstrate to somebody why it works. We also have to, at times, accept waste. And I'm not saying we give in, but sometimes we've committed to something that if you're always striving for 100% of something, well, at times, 50% of something is better than 100% of nothing. And they might have invested heavily in something. There might be an alternative. We should be looking at that. We should be open to challenge. We should be listening to people from different experiences, different backgrounds. If you've done bridge exams, it's about presenting a case. It's about, sometimes you've got to have that right ear and you get lucky with that. Other times you've just got to be really obnoxious and put it in the face of somebody and say, this is what we need to do. I've done that at times with success. I've done that at times with absolute failure. But we shouldn't be too scared to fail. Some really good ideas. We've had a couple of questions around called challenge conditioned. When Paul Rutter embarked on the modernising maintenance challenge, he knew he's got thousands of people's hearts and minds to change. 7,500 or so people we need to change the hearts and minds of. But he took on the challenge. It's not going to change everyone's hearts and minds. He might focus on the ones that's a win. So if there's somewhere where you can demonstrate success, test sites or one function, or use that willing volunteer, that person that's going to embrace the change. And if you've got a load of people that aren't going to do it, perhaps don't put the effort into them. Just ignore them and let them toil away and not achieve the successes that others can. But don't be afraid to be disruptive.
Thanks, Chris.
Dan, you've been waiting.
Thank you for a very good presentation. Lots of thought-provoking bits. Thank you for the PWI for opening its presentations to us mere signal engineers. 2 questions, loads more questions, but I'll concentrate on the 2.
As I travel around both of our routes, I look at infrastructure and think we don't need that infrastructure anymore. And that has to be the fundamental of your challenge of, are we doing the right work? Well, the fundamental bit is, do we even need that bit of infrastructure anymore? We still sit on an asset base that's based in our collieries, coal-fired power stations, and we only have a few biomass power stations left. So my first question would be, what's East Coast Group doing in terms of managing its asset base to be fit for CP7, CP8 traffic flows?
So I agree. I look at the infrastructure we've got, and I think some of it we perhaps don't need it where it is, but we do need something. And it's a real challenge I have around ECDP and the digital program. So if we go to a world where signals away, I'm a track engineer. If you don't have signals, why can't you run a train in any direction on any line? That's what I really simply think. And someone go, well, crossovers are all set up to be facing this way, trailing that way. And the infrastructures, perhaps we need the same number of point ends, they're just in the wrong place. And the Northumberland scheme that I was involved in enhancement, we did a load of work around S&C rationalisation. We had to put new junctions in. Actually, you end up with exactly the same number of point ends and you operate in a different way. So we've really got to think about what it's in. I totally agree. What do we need? Where do we need it? And actually, do we start to do some of this stuff that, how do we challenge it? Let's put a crossover in because it'll help us in the future. Anyone know what you want to do? I'm gonna buy a lot of tickets tonight. Yeah. So I think we've got to look at that. Northumberland was a really good scheme. They've abandoned loads of. They'll abandon just the point ends, and you look and there's a load of other assets that it wasn't cost effective to remove. So I think we've got to do that. I come back to that point of 50% of something or 100% of nothing. I don't think we ever know what we want, therefore we don't do it. And actually just commit to something and you'll get some benefit. Commit to nothing and you'll get no benefit. So I think we've got to, again, make decisions, which I don't think we do enough. And my second point on that is I'd come back to Aurora. I'd make it easier for track engineers to remove assets that we don't need. And how can we get our signalling into an interim state so that we can remove that?
So is that challenge, or is the whole industry challenge of whenever we do say we want to abandon something else, it's very difficult because we always get objections to it.
Yeah, we do. And there are. And every week in the East Coast Control Room, they talk about TSRs and speeds and the longest running speed that we've had on the East. The longest running TSR is actually one that I imposed. It's at Crowell. It's for level crossing, sighting, safety, and the Fox have refused it for 10 years. We can't put a PSR and we can't build a bridge. There isn't enough land. There's a canal. There's all sorts of things. You can't do anything. We either run trains and put the passengers at risk, or we turn around and go, this is the way. This is the Hartley curve. It's 198.4 metre radius. There's only so many things we can do in this point, and the industry needs to be more open to not just what is mine, but what's everyone else. Second question.
So the experience of signalling in the data and condition monitoring space is that we are now overwhelmed with data, so data rich, we're probably information weak and decision poor still.
Yeah.
That's after, I think we've been having RCM for, we'll round it and say 15 years. What lessons is the Permanent Way discipline taking from its signalling brethren in what has in some areas been very good, but in terms of the overall infrastructure and training of people, and probably that hearts and minds piece I think somebody else mentioned. What lessons are you taking from what we've already in some areas, not so messed up, but could have done better?
I've just seen who's on the call, and I remember that I am being recorded.
I was thinking exactly the same as that. Where's that question?
I'm just not doing it. It's the bottom line, Dan. There's a lot of companies that knock on my door, ring me, walk past my desk and say, "Can we talk to you about such and such?" And I go, "Yeah, you can talk to me about it, but I'm not there yet. Unless we know what we're going to do with it and we can fit instrumentation to places, unless we know what those alarms are going to be, why go and fit it?" Because the flight engineers, they spend probably 60 to 80% of their day cancelling alarms. And those alarms are where the S&T have come along and they haven't rung up, say these points are going into maintenance, and they pump them over and it takes a long time and it looks like there's points failing. We go, "Oh, okay then." So a lot of it is we've not built the systems, the flight engineers, we need. I imagine that when we go over to control, it should look like McLaren's control center, but it's not. It's someone with 5 monitors, and you saw what radar looks like. My approach is don't do it. If we can't cope with the data or we don't know what we're going to do with that data, why invest? And there's times you've got to start investing something to work out, is there value in it? I think the TA could really help us with that. Certainly around instrumenting S&C, we can see loads of times that actually we've got rid of all the voiding, yet we're still getting problems. We're still getting broken crossings. We're still getting points failures. We're getting resonance, and we're starting to see that, which is great. I don't know how to fix it. Go repad it. Go lift and pack a bit. I don't know. Keep living with it. So until we get past that, if I don't know what I'm going to do with the data at the end of it, why collect it? So just ignore people's phone calls is my current approach.
Thank you, Chris.
Any other questions for people? Yeah.
I see more in newspapers looking at utilisation of railway at night. So freight, your overnight passenger trains, which is for us prime time to fix the tracks. So how are the people that are looking to, for one word, sell the access, talking to the people who maintain the track to make sure that we don't lose, we're being forced towards that more and more. And how do we not lose that, I guess?
I remember when I first started on the railway, I was asked, John Armitt, the then chairman of the railway, came to meet the graduates and came for dinner, and I got the opportunity to have dinner with the chairman on my first day of Network Rail. And I was like, wow, what am I going to ask the chairman of Network Rail on my first day? I've been here 8 hours and I don't really know anything. And I went on the newspaper. I was like, postal service has stopped. Brilliant. Got a topic there. That's John Armitt. So, John, what do we think about the fact that the postal service has stopped? Are we concerned about a loss of revenue? Get in. First day, chairman. I'm going to be chief exec in 5 years. He said, I'm really glad, because that's given us the opportunity to now do the maintenance. Not the best question to ask the chairman on the first day, but anyway, it was really interesting because actually back then it was, we need to think about it. You talk to Andrew Haynes now and putting passengers first. We're here to run a service. We're here to, what's the point of having a railway if we tell people you can't come on it? It's just, there's no point. There's times that the postal service is a real problem for us on the East Coast. So from just south of Newcastle, the Royal Mail train comes out, it's electrified. So we can't get any isolations midweek because of the mail train. Actually, access isn't always a problem. We can run some trains. There's a Coca-Cola train that goes from Donny to Miller Hill, takes empty bottles. Our lead access, our head of planning loves Coke. So he's like, don't stop that train because that's my favourite drink. But that train running is fine because it's diesel hauled. If it's delayed a little bit, the industry needs to be more flexible. If the mail train was loco hauled 1 week in 4, we could get isolations 1 week in 4. Decarbonisation, that's great. We've got conflicting priorities. We could take line blockage between trains. We've got an access strategy. 1 week in 6, we get that anyway. But because the mail train runs on the adjacent line, we can't isolate it. So that 1 week in 6, if we could change the haulage, we could change it. And this is where we come to pin brazing, changing the haulage of one train for 1 week in 6. What time does the first service leave? Do we do such and such? Again, we've got to think as an industry and be quite open to challenge and not necessarily think about our one individual component. On the East Coast, we've just had Section 7, a disruptive access opportunity. We've had two actually this year, week 7 and 23, I think it was, where we've done loads of work on a Tuesday and a Wednesday. And you go, why is the East Coast shut on a Tuesday and Wednesday? Because it's busier on a Saturday and a Sunday. And David Horton at LNER is really open to shutting the railway midweek because he knows that he doesn't have to then shut it on a weekend. And that's where he's getting his revenue. And that's where he's getting his passenger growth. And that's where his business is right now. So actually, he's open to it. He's having some really constructive conversations. We did miles of tamping, we did loads of cables, we did some signal head renewals, we did some overhead line maintenance, we did some vegetation management. We've done a load of good stuff on a Tuesday and Wednesday. And you can get as many tampers as you want. You can get a Kirov crane, you can get 3 Kirov cranes, you can get 20 ballast trays. You can do whatever you want midweek because the plant's available. So we've got to, I think, be a lot more open to, it's not just nights, it's not just weekends. On Northumberland line, they're looking at putting Section 4 access in for maintenance. So in the rules of the route, Section 4, do not sell any freight paths between midday and 2. The only paths that can go are these 3 passenger services, which means that you get a 20-minute line blockage of a single line every day at lunchtime, on days, in daylight. That's completely different. And that's brilliant. And when Northumberland comes in, look at that and go, we were open to different. No one wants them freight paths anyway. They don't run. They run 6 trains a day. It's to Lynmouth and back, and it all comes down to the tides. So why can't you just run that a little bit earlier or a little bit later and manage to give someone actually some good, decent access? Think differently, take challenge, be prepared to be disruptive, and if you've got an idea, just find the right ear. Anything else? Conscious of time? Thank you all for listening. Hopefully you'll have me back and I can tell you about what modernising maintenance is. And you can challenge Dave Morgan in November about track worker safety.
Brilliant. Right. Yeah. Thanks, Chris. I think we'll show appreciation. Presentation. So just to remind us, the next PWI talk is in September on 21st. That's back here at Gareth Dennis. And also on the 20th, so on a Wednesday, if you're really keen. And there's the NEREF, which is the Northeast Railway Engineers Forum, which is a multi-institution event at Priory Street in York on the reopening and de-rationalising the Northeast Railway. So yeah, everyone, if anyone's in the room, if you can take your cups of tea point, that'd be really helpful. And if anyone wants to go to the pub after, we have a little trip to the York Tap. So yeah, thank you.
Thank you.